Hi folks, welcome to Astronomy Live. Back for night 2. It's going to be a short little live stream as I do some tracking of Artemis 1 as it returns towards Earth. I've currently got a telescope in New Mexico taking pictures on itelescope.net. Got some high altitude haze and clouds that the scope is dealing with over there, but it's getting pictures nevertheless. So as I download those pictures for my telescope, I'm going to be processing them and adding them into this little time lapse that I'm collecting. So you can see the Orion spacecraft moving as a little streak of light in the images here. I'm going to adjust the brightness and contrast of the next version of the time lapse to try to brighten that up, make it more obvious in the video here. And yeah, we're just going to have some fun doing some live data collection from iTelescope. So I had a lot of fun last night doing it with my own scope, but without auto-guiding capability right now, as I don't have my auto-guiding cable, the unguided image tracking is a bit messy and not super ideal. But it was definitely worth a shot last night, as it doesn't cost me anything. And with iTelescope, you do get happy hour, which I'm currently using. So during full moon nights or close to full moon nights, they open it up for members to have 1 hour of free telescope time on one telescope of their choice. So everybody tends to dive in and take full advantage of that. So you see a lot of sort of unplanned observations going on around full moon where there's no reservations, but people are taking over the scopes and using their happy hour, free hour on the scopes to do some imaging, oftentimes narrowband imaging. In this case, we're not doing narrowband imaging, we're just using luminance filters, full spectrum, to be able to shoot Orion here, because it's not like it's a nebula that we can get benefit out of doing narrowband imaging, and that's okay. So I've got a few more images here that are ready for me for iTelescope. So I'm doing 1-minute images, 2x2 binning with the T19 telescope on itelescope.net. I mean, these scopes are just absolute monsters of telescopes. So T19 specifically, this is a, what is this? This is a 0.43 meter f6.8 plane wave. So this is a 17-inch corrected Dahl-Kirkham astrograph, and the camera is an FLI, Finger Lake Instruments camera, just a fantastic deep space camera with a 16 megapixel sensor. I mean, just absolute monster of a telescope. So it's doing just fine in terms of tracking Artemis right now. Just uncompressing the zipped up images that I have here. So I've got a few more images to throw into the time lapse. And like I said, I'm going to try to adjust the contrast, make it a little bit brighter, hopefully not mess things up too much here. Oh, we can do better than that. We can do better than that. Let me see here. Go for that. Okay, maybe that'll be a little bit brighter. I can crank it more if necessary. So I'm running this through a custom Python script I wrote for handling FITS files. It tries to automatically correct for the median value of the image, which is very important here because we're getting some very highly variable levels of cloud cover from image to image. And so if you don't handle the brightness and contrast dynamically, you get one image that's really washed out and the next image not nearly as much. So I'm dynamically handling that by looking at the median value. So I don't know if... Okay, it looks like OBS is automatically updating to the new version of the file, which is nice to see. So when I overwrite it, with new images, it automatically updates. You can see some degree of flashing of the background there. Again, that's the wispy cloud cover that the telescope is currently peering through. And my program is doing its best at sort of dynamically handling that based on the median value in the image. It'd be a lot worse if I weren't doing that. But there's some still residual variability in the overall sky background level, and there's not much I can do about that in real time. But that's okay. I think you can see Orion there clear enough anyway. I'm going to go ahead and move this around a bit, zoom in and enhance. Well, not really. Just zoom in a little bit more so you can see Orion there. So I'm collecting image 19 of 35 right now, but I don't have all the images downloaded yet from the telescope, of course. So I'm just getting them as they get uploaded to the FTP server for iTelescope. Will I capture the lunar occultation? Not really. The lunar occultation of Mars does not apply to Florida. Mars will not be going behind the moon from Florida. In fact, from Florida, it's not even all that close. It's kind of close, but it's not close enough where you would see the moon in the telescope's field of view if it were shooting Mars with any sort of reasonable focal length. Yeah, that moving speck is Artemis. That is Orion. That is the Orion spacecraft. And I'm about to go add even more images to that time lapse that I've got going there. So let me check on the FTP server here. Got 3 more images to add on to that time lapse. And again, each image is 1 minute long, so that's how each frame of this time lapse is how far it moved in 1 minute of time. So just keep that in mind as you're watching it. Okay, I'm going to extract these. So I'm extracting some zip files, some zipped up FITS files, and now I'm going to pass them all through my program for processing them into this time-lapse video, so it's automatically processing that right now, and it will hopefully update with the new time-lapse here in just a second. That's why it's frozen. It's writing a new file. There we go. So 3 more frames on there. That little dashed line you see streaking through the view there, approaching the center of the view, that is the Orion spacecraft. Right now, as it's making its way back to Earth from the moon. According to iTelescope, it's currently 20 degrees from the moon in the sky, which is quite a big change from last night when I was trying to track it with my own scope, where it was only 5 or 6 degrees, I think, from the moon. But now it's far enough away that I can safely point one of these big scopes at it and have good confidence that we can see it here. Not a problem. Okay, got a few more frames. Downloading the new FITS files. Okay, so we've got another 5 images here. I'm just going to throw these into the time lapse again. So how's everyone doing tonight? Hope everyone is having a fine Taco Tuesday. Out again, so it's going to update the time lapse with even more pictures. That's coming along nicely. Yeah, this is going to make a nice little clip when it's all said and done. Currently on image 23 out of 35 that I've got scheduled to take. If you're enjoying what you're seeing, please hit that like button. It'll help more people see this live stream so they can come join us and watch the Orion spacecraft falling back to Earth. So we have here on the left the live stream from Orion, from NASA. So we can see Orion looking into space there. Not a whole lot going on there, but still, it's kind of cool. We've got the view from the spacecraft and the view of the spacecraft at the same time. So I just added a few more images there that I got from the telescope. on image 27 of 35 now, in terms of pictures currently being taken. Currently on image 22 that I've got downloaded so far. And as more of them become available on the FTP server, I'll download them as they become available on the FTP server and put them into the time-lapse we're gradually building here. So again, you're looking at the Orion spacecraft as it comes back to Earth at the end of Artemis 1. Yeah, so for clarity, this is an extremely cropped view of the total field of view of the telescope right now. Um, because it's a 16 megapixel imager on this beast, we can do that without really worrying about any real loss of quality. But if I zoom out, so just to show you the whole frame, it's massive, and it can easily hold the Artemis 1 Orion for quite a period of time. We could go for hours. Well, I'd say probably at least an hour before it left the field of view. Here's the total field of view. I mean, it's just, I can't even fit the darn thing in here. It's so big. There we go. Even then, okay, this is the whole field of view. So Artemis 1 is just this little dot in the middle of it, passing through the center of the field of view. But in total, it encompasses a much wider field of view. And that field of view is about 43 arc minutes on a side. And as Dave pointed out, that's about 1.5 times the width of the moon. So it's a massive field of view for this imager. So that's why I'm cropping in here to a much tighter field of view, so we can just pay attention to the Orion spacecraft in the frame. So checking, let's see. Okay, we've got some more images to download and put into the time lapse. I'm going to go ahead and do that now. So you'll see it freeze in a moment when I go to process that. So, I have now the last image that I'm going to take tonight with T19. I'm going to go ahead and add that into the time lapse. So I'm going to render that now. Then what I might try to do, so there we go, there's the full time lapse of all 35 images, taken over nearly an hour of time. And now with this data combined with the astrometry I gathered last night, I can try for an orbit solution and see what we get. So what do you guys think about that? So while this plays, I'm going to go ahead and astrometrically solve just a few of these. I'll get the full data solved later. I'll have to boot into Linux in order to do that, and I'm using my desktop to stream right now, so I can't do that. But what I will do is I'll upload a few of these images and see if I can get astrometry.net to solve them. As with last night, I did have trouble with it earlier this evening, so I'm expecting to encounter some resistance there from their servers, but hopefully I can get at least a few of these to solve, and then measure the astrometry off of that, and then put that into FindOrb and see if we can come up with an orbit solution, especially when combined with at least one observation from last night to give it a longer span of time to calculate the orbit with. So we'll see what we get there. So give me a few minutes while I work on that. So I've got the orbit solution. I'm going to pull that up and share that now. I think this is rather interesting. So let's see here. Capture. Let me make sure I'm not going to accidentally dox myself. Because I also did include an observation from last night. Where is strange? All right, let me hang on a second. Let me clear out some windows. There we go. Okay, so here's the orbit solution. Yeah, maybe on this side. Okay. Okay, let me move the time lapse over to the right side here. Okay, so here's the orbit solution, which is frankly not bad. Now, I did try to be very careful in measuring the coordinates using SAO image DS9. I've got a Python script that I use for quick and dirty astrometry, where I just sort of click at a zoomed out view of massive images like this to try to get some astrometry data, but do so very quickly, just as a first pass at things. Helps when I'm trying to reduce a lot of data very quickly. But instead I did this by hand using SAO image DS9. And so we've got mean residual less than half an arc second, 0.36. That's one of my better solutions, honestly, from just the 5 observations. So I grabbed 4 images from tonight spanning the 1st, the 10th, the 20th, and the 35th image, and then the observation from last night that I solved on stream. So combining those together, we get a very tight orbit. We get a perigee predicted at 1817 Universal Time on December 11th. Now, what did I say earlier? I said that its predicted splashdown time was 1742, so about half an hour before that. So the timing looks a little off from the current projection of when Artemis 1's going to currently splash down, but only by 30 minutes or so, which is really not bad this many days out with just basically 24 hours of observation, 25 and a half hours of observation, spanning just 5 readings right now. Really quite a good solution. And they may be doing trajectory corrections between now and splashdown. Tony Dunn asks, is JPL Horizon's ephemeris good enough? Good enough for telescopic observations, yes. I will say it looks like it is currently a little bit off from the predicted positions, which is not what I'm accustomed to be frank. With previous spacecraft, previous observations in the past, JPL Horizons has been basically right on the money, and I'd say right now it's parallel. It's definitely parallel in terms of the direction of travel and the position. But if you look at my stream last night, we found that the place where I was seeing Artemis 1 seemed to be about 7 arc seconds off of the JPL ephemeris, which isn't a huge amount, but it's detectable, right? It is detectable at these focal lengths. So that was with my 11-inch scope. Tonight we're using T19 on telescope.net, and I'll pull up SAO image DS9 to show you guys an example of what I'm talking about. So I've got image 10 pulled up on ISA image DS9 right now. But before I skip over to that, I do want to point out something else here about the find orb solution. You look at the little Q, small Q in the solution. Let me see if I can pull up here with my cursor. So I think this is showing my cursor on stream. 6483.6. 6483.6 right here. Plus or minus 98. This is the predicted perigee distance, which has an uncertainty, give or take, about 100 kilometers. 6,483 from the center of the Earth. Now, Earth's radius is about 6,378 kilometers, I believe. So you figure this is showing that it will approach Earth. The nominal solution I have here from my observations shows an approach to Earth with a perigee distance of about 100 kilometers above the surface, which is in the atmosphere pretty much. And again, we have a little bit of uncertainty in the position because we only have a relatively short span of observations here, and just 5 observations from tonight, combining with last night. And so if you give or take 100, well, that's, in other words, the nominal solution shows that Orion is going to approach Earth to within 100 kilometers of the surface, give or take 100 kilometers. Well, there you go. It's going to hit Earth's atmosphere. It's going to re-enter, according to my solution here, my orbit solution here, from the observations just from tonight and from last night. Before that, I did do observations of it, throughout the journey, pretty much from launch to one orbit after launch, and now we're finishing up observing the spacecraft as it returns to Earth. But at each of those phases, it's performed various maneuvers and burns. And Find Orb doesn't know that. It doesn't normally handle that kind of thing. It's designed to work with natural celestial objects, tracking comets and asteroids and things like that. It can track spacecraft like this, but when said spacecraft are doing maneuvers, it doesn't know what to do with that data, really. By default, at least, it doesn't really know what to do with that, because it's assuming Sir Isaac Newton's in the driver's seat, basically, right? So when you have maneuvers, you kind of need to break it up into different phases of flight. So we can look at the observations from particular phases of flight, like when it's in the distant retrograde orbit, which we have observations of, and when it is traveling to the moon after TLI. I've got those observations, and I did an orbit solution for that in a previous video. But now we're in the return phase of flight, so it's done the return-powered flyby maneuver, and now it's basically falling back to Earth. It will perform a trajectory correction at some point, I'm confident, but those corrections are minor compared to the large burns it does, say, near the moon, to either send it out to the distant retrograde orbit or now to send it back to Earth. So those are much larger maneuvers with much larger dispersions, but when it performs small trajectory corrections, we might see this mean residual here increase. Right now it's very tight, so this suggests they have not yet done a correction burn. I might be a little premature in saying that because I'm only using one observation from last night, so that does not account for, or that doesn't really show the program what the velocity was last night, just the position. If I get at least 2 observations from last night, then I can actually determine what the velocity was last night. But at least I'm fixing the position that I saw it at the beginning of the pass that I captured last night, and that helps link the orbit to a much earlier observation than just the hour of time that I've been observing it tonight. So it's got a much more firm solution. Scott Manley did a video about this, about how asteroids are discovered and how their orbits are calculated. Really nice visual breakdown of this. And oftentimes, it's not just the number of observations. It's not even really the number of observations that's the limiting factor to the accuracy. It's usually time itself. The longer a span of time you have that your observations cover, the more accurate the orbit solution. So, as we collect more observations, if I come back tomorrow night and do this again, then we'll have even more data to work with and an even better solution, right? Assuming they don't perform a large trajectory correction. Even if they perform a relatively minor trajectory correction, you'll probably see this number increase, is my guess. 0.36 arcsecond mean residual. That's extremely small. That's smaller than the angular resolution of these photos, I'm pretty sure. Let me go double check that. I'm pretty sure it's the case here. So, yeah, these observations tonight, we're looking at 1.26 arcseconds per pixel on astrometry.net. So I'll send you a link. I'll put it in the chat here, a link to one of the solved images. So you can go download that. You can download the data yourself. So yeah, these images from tonight have a resolution of 1.2 arcseconds per pixel, because I'm binning 2 by 2, and that's significantly larger than the residual itself, which is amazing. So we're getting a very good solution here. So let's go over to SAO Image DS9 now and actually look at how my observations stack up to the JPL ephemeris and take a look at the deviations there from the expected trajectory. So JPL horizons will provide you an ephemeris that shows you where JPL expects the spacecraft to be, and we can compare that to where we actually see it in these images. So let me see here. I'm going to go over to SAO Image DS9, and I'm going to share that screen on stream. So already, though, I mean, I just love it. It tickles me when I see it like this, where we collect these observations, we do our own calculations based on it, and we find out that we come to agreement with NASA. We find out that, yes, this spacecraft is headed back towards Earth's atmosphere right now. It's coming to within 100 kilometers of Earth's surface, plus or minus 100 kilometers. That's perfect. And it's going to do so within half an hour of the predicted splashdown time. And that's before any trajectory corrections occur. Excellent. It's just excellent to me. So, all right, so here's SAO Image DS9. I'm going to shrink this down a little bit. Okay, so here's SAO Image DS9. We can blow that up a little bit. So this is image 10 from tonight. This is the 10th image I took. And let's see here. I'm going to get the region information on this. I'm going to share that window as well. So I've got another window here to provide. Okay. So this is the astrometry. Get the coordinates in WCS format. So there we go. So there's the coordinates, the radius in, say, arcseconds. So let me zoom in on this some more. It's better on stream. Okay, there we go. Okay, so I put the circle right at the start of the streak. So this top right corner is where the streak begins in the start of the exposure. If you look back at the time lapse, just to remind you, you can see it's moving down and to the left. So the very top right corner of the streak corresponds to where the spacecraft was as the exposure started. When the shutter came open, that's where the spacecraft was. So if we use the exposure time in the FITS header information, we can see that this particular exposure 10, was taken at 2:47:07 universal time. And I'll share that on stream here in just a second. So it was 6 times 10, so 60 seconds exposure. And you can see the date of observation there, 2022, December 7th, 2:47:07.59. UTC date time of exposure. So we can plug that into JPL Horizons. The observatory is code H06 for iTelescope in Mayhill, New Mexico. So I'm just going to grab this. I'm just going to copy that time over to JPL Horizons. Okay, and then JPL Horizons gives me the predicted coordinates in J2000. So the astrometric coordinates, I'm now going to take that and put it back into SAOHDS9. So I'm just going to create a circle here in SAOHDS9. And I'm going to get the information on that one. Okay, turn that off for a second. Okay, so this is going to be our JPL prediction, and we're going to load our coordinates into that. So right now we haven't copied the coordinates into it yet, but I'm going to go ahead and show. Okay, so this is, I gotta fix that, but this is the, okay, so this is going to be the coordinates of the JPL prediction. So we're going to copy the coordinates. I'm going to copy it off of Horizons, JPL Horizons. And I'm going to paste that in here. Okay, this is where JPL predicts the spacecraft was at the start of the exposure. Okay, so you can see there, it's not quite in the same spot. Say 5 arc seconds here. Okay, so those circles are now the same size. So yeah, this is where it predicted the start of the streak would be in the image. You can see it's a little off. It's not quite there. It's a little down and to the right of where JPL predicts it to be. Now let's see what that distance is. Let me measure that. So we get a line going here. Just going to draw a line. And I'm going to pull up that region information there. Okay. And I'm just going to call this JPL error. Okay, now I'm going to share that information. Okay, so we're going to copy the coordinates from the two lines below it, this one and this one down here. We're going to copy this into the points of the line. So this, oops, for, okay. Okay. JPL prediction, paste that into the second part of the line. Okay, and now we're going to measure the length in arc seconds. So there we go. It's 11 arc seconds. 11 arc seconds off from the predicted position. Now last night when I measured it, it was about 7 arc seconds. So I'm not sure if that just means the spacecraft is slowly deviating from the predicted orbit, or is it just a perspective issue with last night's observation being in Florida versus tonight's observation being in New Mexico? Also, the spacecraft is getting closer to Earth over time. So if it were at a fixed distance from the predicted position, that distance is going to subtend a larger angle over time. In other words, even let's say it was 100 kilometers off of the target position. They were trying to target a position for it in space. It's 100 kilometers from that position. That 100 kilometers is going to be a smaller angle when it's very close to the moon, having just left the moon last night, versus tonight where it's a little bit closer to Earth. So it may not truly be getting further from the predicted position in space, but it's getting further from the predicted position in the sky. Not by much, but it's now 11 arc seconds off of the predicted position by JPL, which I think is an interesting observation at the very least, and does suggest to me that they'll probably do a correction maneuver, I would assume, at some point. But even if they didn't, again, based on our orbit solution tonight, we can already see that it's going to come back to Earth. It's going to come back to a spot about 100 kilometers above the surface, plus or minus about 100 kilometers on December 11th. So that's all looking good. That's all looking real good. So I'm going to finish up processing these images that we recorded tonight. I'm going to astrometrically solve all the pictures locally on my desktop. Again, I've got to reboot the machine into Linux to even do that, but I am going to do that before I call it a night, and then tomorrow I'll run that through the program and pull up the predicted position from JPL. Now by tomorrow, maybe, I don't know if they'll update JPL to reflect its actual position versus the predicted targeted position, but if they don't, then it will show it's running parallel to, but a little bit off from where it's predicted to be, which again I think is interesting nevertheless. So that's going to pretty much do it for I think the live stream tonight. So again, here's the time lapse that we recorded tonight using T19 on the iTelescope network, which is a excellent telescope, plane wave in New Mexico on the iTelescope network. So this is a 17-inch corrected Dahl Kirkham on the iTelescope network, and it did a fantastic job capturing the Orion spacecraft tonight as it heads back towards Earth. So now that I'm losing my voice, I'm going to call it a night. But thank you all for coming and watching. Hope you enjoyed the stream here, and we'll continue collecting more data as long as the weather holds out as Orion makes its way back towards Earth. Till next time, thanks for watching, and clear skies.